Okay, so what we're looking at next, transformational logarithmic functions. All right, so well, when you're transforming the graph of a logarithmic function, the first thing is you got to have some base points. That's true with any graph to use our equations. And so the standard ones that I use is I use 3 x's which have corresponding 3 y's. And so what I'm looking at again with the logarithmic function, this is the y value represents what would the exponent be on 10 to get your x value. So 10 to the negative 1 will give you an x value of 1/10. Just like 10 to the power of 0 will give you an x value of 1. Or 10 to the power of 1 would give you 10. And so if I graph the log function, let's see, I'll use a different color. 1/10. That's really small, and I'd be down here at say negative 1. Again, just a sketch. Then I have an x value of 1. It would be 0. So right in, let's say right in here. And then an x value of 10, somewhere down here, our value would be 1. So there's what your logarithmic scale or graph looks like. Now here's one key that we're going to be using right now, is that no matter, because of the definition of a logarithmic function, easy for me to say, no matter what exponent you put in there, it will never, your x value will never be negative. It doesn't matter what y value. So there is actually a vertical asymptote at x equals 0. All right. Now, as we transform the log function, that will change. We'll get into that. All right. Just want you to be aware of it. All right. So I'm going to look at example 1 here. It says, in words, describe the transformation that must be applied to the original log function, which is log base 10 of x. All right, so I'm going to do let's go with B and C. B and C. We'll get right to the hard ones here, or more involved ones, I should say. All right, so B, it's basically identifying where your A value is, your K, your D, and your C. All right, again, from transformations from before. And so I have a transform function here, g of x. So f of x is our original function. We have -2 log, because it's base 10, I don't even really have to write 10 because it's just assumed. X plus 5. All right, so the first thing is, now we're doing this in words, okay? So I'm going to look at the A value. Now the first thing is, because it's 2, it's being vertically stretched by a factor of 2. All right, so that's the first thing with the A value. But I also have a negative sign. Because I have a negative sign, and the A value has to do with the Y, but it's reversed in that what the Y's with the negative sign happen is they flip. And what they do is they get reflected, what's a nice word here, across the x-axis. All right, so again, in words, now I look at the K value. It's sneaky, it's a secret one right here. Because it's 1, that means there is no horizontal compression or stretch, and there's no reflection across the y-axis. All right, now I look in here. This is where we have a horizontal translation. And again, this is always the tricky part, messes people up. There's 2 parts that mess people up, but this is one of them. The plus sign actually means that this is going to be shifted left 5. Always looks the opposite. And again, we have no C value here. Well, we do. It's actually plus 0. So there is no shifting up or down. All right. So that is in words what is happening to this log function. C. Let's see. So now we have a new function. G of x is equal to log. Again, it's base 10 if I don't bother to write it because it's assumed if it's base 10. We have a -4, x plus 1, and then outside that function, we have a plus 8. All right, so in words, what's going on? I look at my A value. It's 1. So there's no vertical stretching or vertical compression. And it's not reflected, because there's no negative sign, it's not reflected across the x-axis. So I don't have to worry about that. Now we get to my K value. Now this is where things are a little bit different. Number one, we have the negative sign, which means this thing is going to be reflected, this transformation would be reflected across the y-axis. All right. Now, the fact that the k value is actually 4, so this is the other trick. This is why I wanted to do B and C here. K is 4, or sorry, I should say it's -4, but we already dealt with the negative sign. But what you talk about in terms of words is that the graph is going to be vertically, we're dealing with K here, horizontally compressed. So I'll put a little HC, horizontally compressed by a factor of 1/K. So what's 1/4? So those are the two things that mess people up there. All right. This D value always looks the opposite. And then when we're talking about the K value, you go 1/K when you're talking about it. Even though the K value is 4, it means we now, because it's less than 1, we have a horizontal compression by a factor of 1/4. All right. And then again, dealing with the other stuff, there's our D value, which is -1. Again, always looks the opposite. So that means this one is shifted left 1. And we do have a C value of 8, which means this is going to be moved up 8. So that is how I would verbally describe the transformations that are going on with those two functions. All right, now we get to example 2. So okay, so example 2, we are now going the opposite way. Giving you some words. We got to come up with what is happening. All right. And so we get the first one here. So example 2A, it says it is vertically stretched by a factor of 3. I'm just going to pause right there. Pause right there. If it is being vertically stretched by a factor of 3, that means my A value is 3. Now, here's something that could throw you off. The next part says it's reflection across the y-axis. So that sometimes people think, well, it's the y-axis, got to have something to do with the A value. No, if it's reflected across the y-axis, that means our K value is negative. And since it doesn't talk anything about horizontal compression or stretch, that means our K value is -1. All right, then it is shifted left 5. Left 5 means that our D value is going to be -5. And there's no up or down whatsoever on this one, so that means our C value is 0. So if I wanted to write this equation, I have y equals 3 log, what's our base here? Oh, the base function is 10, so I can just leave it as log, or I can put a base 10. They are the same thing. All right, then it is, reflect the K value is -1, so put a -1 there. Then I have brackets, I have an X. Again, there's supposed to be a minus sign, but the minus sign from the D and the minus sign from the equation come together to give me a plus, so I have a +5 there. And so that would be me rewriting the transformed equation. All right. B. So we'll go the other way here. Same thing, same way. So I'm going to just take the words and make them into math. That's the hardest part about math in every grade, every level that I teach is English to math. All right, so I'm just reading the words here. Reflected across the x-axis. So the x-axis is referring to the A value. And that's telling me my A value is negative. It's horizontally stretched. So I guess it's not talking about the A value anymore. It means my A is -1. Okay, now here's the tricky spot. It says it's horizontally stretched by a factor of 4. Now, when the words, this is the trick here. What is that? That's telling me that 1/K is equal to 4. That's what that's saying there. So that really messes people up there. Now, if I solve this equation, that's telling me that k is 1/4. All right, so if you're horizontally stretched by a factor of 4, that means your k value, you inverse it, and it's 1/4. Shifted right 3. D is 3. Up 10. C is 10. All right, so now just to rewrite the equation, now I've got my values here. So I got y equals, my a value is -1. I have the log. It was base 10. Oh, I threw it in there this time. What the heck? My k value is 1/4. Goes in front of the brackets. All right, my d value is 3. So I've got an x minus. Put the 3 in there. Again, it's the minus sign supposed to be in the equation. And then my c is plus 10. So there would be our equation. Again, taking the words. Why is it base 10? Because whenever you just talk about a log function, or it has a base 10. If you look in the above part of that example, it says that the parent function is a base 10. So if the parent function is a base 10, the transform function is going to be a base 10. That's what's happening there. Okay. All right. Examples. Let's try. Let's go with 4 and 6. I'm going to do examples 4 and 6 for transformations. Okay. So 4 and 6. All right. So get rid of this stuff. All right, so here we go. Example 4. Again, our parent function is the log of x, base 10. Here's the g of x that we're looking at. G of x is the transform function where we have the log. Again, I don't have to write base 10, but I could, but I'm not. All right, so I have 2 times x plus 6. Okay, now here's how I like to do this. Students actually showed me this. I'm going to do a little chart. Okay, here's my x values, here's my y values. All right, now these values, I'm going to call them x1 and y1. All right, they are of my original transformed, or my original function. And again, those are the values I did at the very beginning, where my y value is -1 because 10 to the power of -1 means your x value is 1/10 or 0.1. Why don't I put that? 0.1 instead. I hate fractions. All right. 0.1. If my 10 to the power of 0, x would be 1. And then 10 to the power of 1 would be 10. So those are my original logarithmic function table of values. I'm just using 3 of them. Now, here's what we're going to do. First off, I'm looking at my equation. To transform my equations, I'm going to use those transformation equations. And I'm going to rewrite them. I wish I had done this in the first unit or the second unit. So we have 2 of them. We have one for the x and one for the y, right? We have our x1 over k plus d. And that's going to be equal to, and this is the part I didn't add in before, x2. x2 is going to be my x-coordinate, my transform point. x1, that's for my original parent function. Now, there's also one for the y's, right? We have y2 is equal to a times y1 plus c. Again, where y1 refers to the coordinates off our parent function, y2 is our transform function. Now, here's what I'm going to do. I'm going to look at my function here and get my a, k, d, and c values. So I look right here. A is 1. K is 2. My d value, again, trick says plus 6, but really that means d is minus 6. And then the c value over here, there's nothing. So I got nothing. Now, here's what I'm going to do over on this side. I got x2 is equal to, and I'm just going to sub things in here, x1, k is 2, minus 6. I'm going to put that equation right here. I'm going to take my x1 divided by 2 minus 6. All right, now I'll do the same thing here over for my y equation. So I'm going to have y2 is equal to, well, a is 1, so I'm just going to have a y1 here. And c is 0. Okay. Wow, that's a boring example. Did I do that? I guess I did. All right, so in simplified, y2 is y1. So here's my y1. So it looks like our y coordinates, they're not changing. They're not changing at all. There's no transformations because our a is 1 and our c is 0. It's not being flipped, stretched, compressed vertically, and it's not being moved vertically. But here we go. Now, here's what I do here. Is I sub each of these x1s into this equation to get my new transform point, my new transform x coordinates, I should say. All right, so what I'm going to do here is I put 0.1, right, divided by 2 minus 6. And that is equal to, what did I get here? Negative 5.95. That's what that is equal to. So my first coordinate on my transform point is negative 5.95 and negative 1. Then I do it again. Let's see here. I put in a 1 here, 1/2 minus 6. That's going to be negative 5.5. Put 10 in here. 10 divided by 2 is 5 minus 1, or minus 6, sorry, is going to be minus 1. All right, so now when I graph this, I've got 3 points for reference. Now, but before I get to that, I talked about the asymptote, right? The vertical asymptote on the original is x equals 0. What affects the asymptote is the d value. So if the d value shifts the entire, because the d value shifts the graph left and right, it also shifts the asymptote left and right. And so the asymptote for this particular function is going to be negative 6 because the whole graph is being shifted left negative 6. So let's see here. I'll put in my asymptote here, vertical asymptote. There, that's at negative 6. Okay, and then simply what I'm going to do is plot my points. So I have negative 5.95 has a height of negative 1. So yeah, right in here. Again, just a sketch. I don't have a great graph here. Negative 5.5, I have a height of 0. So I don't know, right in here. And then lastly, an x value of negative 1, somewhere in here, has a height of 1. And again, I got to pay attention to my vertical asymptote. And there we go. There's a sketch of our transform function. All right, so again, I start off, write down the function, get my equations, and then use my chart, do some calculations, and then graph the sketch. I know that was all quick. We'll do another one, example 6. All right. It's just got a bit of a wrinkle to it. It's got more values going on, where the y's will be affected also, I believe. Yes, good. All right. I should have left those. All right. Okay, so here we go. Example 6, which again has a little bit of a wrinkle thrown in it here. So our transform function is g of x is equal to 3 log base 10. So again, I don't have to write it. I could. Just it'll get jumbled up a bit. I've got negative 1/2 x plus 2 minus 3. Now, here's the first thing. There's a problem with this one. Is that it's not really written exactly in the form that we're looking for. And then what I would say by that is we don't have a k value here, and we just don't have this x by itself here. So what I have to do to get this x by itself, because that's the proper form that it looks like, is I'm going to factor out this negative 1/2. All right, I'm going to common factor it off the 2, and I'm going to common factor it out of the negative 1/2 x. All right, so I have g of x is equal to 3 log. I factor in the negative a half. All right, I have an x value there. Now, what times negative a half would give me 2? I believe a negative 4 would work. There we go. All right, because negative a half times negative 4 would give me positive 2. And obviously negative a half times x would give me negative 1/2 x. So now I have it in the proper form. I can see my a, my h, or sorry, my a, my k, my d, and my c. And because of that, I'm going to write those down. But first, again, I'm going to write down my equations where I'm looking at that I'm going to have to use. x2 is equal to x1 divided by k plus the d. So there's for the horizontal things that can happen. And then the verticals, y2 equals a times y1 plus c. All right, so again, spotting things out. My a is 3. So I'll write it here with my vertical stuff. A is 3. K is negative a half. Negative a half. My D is a 4. Again, that looks like the opposite. And then my C is negative 3. All right, so there's what we got. So now I'm going to substitute into those equations, all right, to simplify them so that I can go back to my chart and then do a graph. All right, so I have x2. Oops, got the right color here. There we go. I have x2 is equal to x1 divided by negative a half, okay, plus 4. All right, over with my verticals here, y2, my a value is 3, so I'm going to have 3 times a1. Oops, 3 times y1, I should say, y1, and then my c is a minus 3. Now I'm going to simplify this one up. When you are dividing by a fraction, a lot of people don't know this, you invert multiply. So really this is going to be x2, let's see, if I invert negative a half, it'd be negative 2 and multiply. Dividing by a fraction, you can invert multiply. So there we go. I just simplified that equation down to x2 is equal to negative 2x1 plus 4. All right. So now I've got those. So now I go to my table. Get my transform points, right? Do my calculations. So I've got my x1, y1. So those are my original points. Again, x is 0.1, y is negative 1. We have a x is 0, y is 1. Let's see here. Hold on here. No, sorry, got those backwards. Always thinking exponents. And then 10, then we have a 1. All right, and again, I'm just going to copy those equations in. So to find my transform x coordinates, I got negative 2 times the x1 value plus 4. And to find my transformed y coordinates, I got 3 times y1 minus 3. All right, so here we go. Now to do some calculations. All right, so I'm going to plug in 0.1 here. So negative 2 times 0.1 plus 4. So negative 2 times 0.1 is negative 0.2 plus 4, 3.8. Negative 2 times 1 is negative 2 plus 4, 2. Negative 2 times 10 is 20. Negative 20, sorry. Plus 4 is negative 16. Okay. So now next up, we go to our y values. And let's see here. So they're a little easier. 3 times negative 1, because that's what I'm plugging in here first, is negative 3 minus 3. So we got negative 6. Put a 0 in here. 3 times 0 is nothing. And so we're going to have a minus 3. And then put a 1 in there. 3 times 1 is 3 minus 3. 0. There we go. All right. So now to finally sketch this function, let me pay attention to my x values here. Whoa, got all the way back to negative 16 here. All right. That's going to be crazy. I guess we'll do it more this way because I'm only going to have to go 4 that way. Okay. Now, I got to, again, put in my vertical asymptote, right? And again, the original function has an asymptote at x equals 0. The only thing that affects that is the d value, shifting it left and right. There it is. At 4, we have a vertical asymptote because that's our d value, right? So again, a sketch here. There's 4. So there's our VA, our vertical asymptote. All right, and now to schedule or to graph in my points. So I got x equals 3.8. We're down to -6, so I don't know. Again, just a sketch somewhere in there. There's 1 point. I got an x value of 2, just right in there somewhere. -3. I don't know, right in halfway. And then lastly, whoa, got an x value of -16. I don't know, somewhere around here. Y value is 0. And again, it's got to hug our asymptote, and there it goes. And there we go. So that's how we sketch our logarithmic functions. Again, using our equations, but being able to spot them from the original or the transformed equation, knowing what your A, H, and K, or A, I'm used to teaching quadratics, A, K, C, and D values, and using them. Just going to